video is on Unit 2, Chapter 6 on Quadratics Extras, Lesson number 1, Quadratics Application. In Chapter 5, we talked about 5 different methods to solve a quadratic equation. We solved by graphing, we solved by factoring, quadratic formula, square root property, and completing the square. We are going to use some of that throughout this Chapter 6. In this first lesson, we are going to be looking at word problems, and each of these word problems is going to create a quadratic. So let's look first at example number 1. The width of a rectangle is 6 meters less than its length. If the area of the rectangle is 112 meters squared, find the dimensions of the rectangle. So think about your rectangle. It has a length and it has a width. So let's go back and read that again. The width of a rectangle is 6 meters less than its length. So that means length, I'm going to let the length be the x, and then my width is 6 meters less than that. So it's going to be the x minus 6. And we know the area of that rectangle is 112 meters squared. So the length, which is x, times the width, which is x minus 6, is equal to 112. So to solve this, I'm going to first distribute x squared minus 6x equals the 112. Now here again, you can solve this using any method that you like. You can solve using factoring, quadratic formula, completing the square. Looking at this, I'm personally going to use completing the square. The 112 is already on the right where it needs to be for me to do this by completing the square. And the x squared and the negative 6x are on the left. So at this point, I'm going to add the b over 2 squared to both sides. So b is negative 6 divided by 2 is negative 3. Squared is a positive 9. So I'm going to add 9 to both sides. And I've got x minus 3 squared. I'm going to factor the left now. It factors into x minus 3 squared equals 121. Now I can square root both sides, and x minus 3 equals a positive and a negative 11. And I can set up my two equations. Add 3. 11 plus 3 is equal to 14. And then when I add 3 on this next one, I get x is equal to negative 8. Now, the issue here is that the length is x. Length cannot be a negative number, so the negative 8 is just basically going to go away, and we're left with the length is 14 meters, and the width would be 14 minus 6, or 8 meters. Let's look at number 2. Number 2 says the length of a rectangle is 1 foot more than twice its width. If the area of the rectangle is 300 feet squared, find the dimensions of the rectangle. So this one's very similar to question number 1. We're still dealing with a rectangle, and we have length and width. The length of a rectangle is 1 foot more than twice the width. So in this instance, width is going to be our x. And again, your length is 1 foot more than twice that. So 2x plus 1, or you could put 1 plus 2x is the same thing. We know that the area is 300. So the x times the 2x plus 1 is equal to the 300. And I'm going to distribute. And I get 2x squared plus x equals the 300. And again, you get to choose what method that you want to use to solve this, whether it be factoring or quadratic formula or completing the square. It cannot be square root property because we have an x in the middle. I am not going to use completing the square on this one because I would have to divide everything by 2, and that's going to give me a fraction for the b. And I'm just going to subtract the 300. And then factor my trinomial. So 2 times negative 300 is negative 600. And then they need to add to give me a positive 1. That's going to be Two numbers that multiply to give us 600, that add to give you a positive 1. I can tell you that that is a 25 and a negative 24. So then I'm going to substitute that in. To replace that middle term. And then I'm going to factor by grouping. So I'm going to group the first two, group the second two. In the first set, the GCF is just an x. And we get 2x plus 25. The next set has a GCF of negative 12. And that gives me 2x plus 25. And then from there, the 2x plus 25 is my one factor, and the second one is the x minus 12. Now, the x minus 12 is the easy one to solve here, and I'm so out of room, but x minus 12 equals 0. Add the 12, we get x equals 12. For the 2x plus 25, let me come to the side here. 2x plus 25 equals 0. You're going to have to subtract the 25 and divide by the 2. Negative 25 over 2 is like negative 12 and a half. Again, your width cannot be a negative number. So that's going to go away. And our width is 12 feet. And then 2 times 12 is 24, plus 1 is 25 for the length. We're going to ignore that phone. I'm just going to keep going. Example number 3 says the dimensions of a rectangle can be expressed as x plus 6 and x minus 2. If the area of the rectangle is 65 inches squared, find the dimensions of the rectangle. Here again, it's a rectangle. This is the same setup. You would multiply the x plus 6 times the x minus 2 because that's the length and the width. The area is 65. We have to FOIL the left. So x times x is x squared. X times negative 2 is negative 2x. 6 times x is a positive 6x. 6 times negative 2 is negative 12 equals the 65. So at this point, I'm going to combine my like terms on the left. X squared plus 4x minus the 12 equals the 65. Now we've got a quadratic. At this point, you have to decide if you're going to solve by the factoring, quadratic formula, or completing the square. I am going to complete the square. So I'm going to add the 12. Remember that with completing the square, you want your constant to be on the right. So 65 plus 12 would be 77. And then we're going to add b over 2 squared. So 4 divided by 2 is 2 squared is 4. So I'm going to add 4 to both sides. Factor the left. X plus 2. Square root of 4 is 2. Whoops. Let me fix that really quick. Square root of 4. I forgot to take the square root. Squared equals 77 plus 4 is 81. Square root. And x plus 2 is equal to a positive and a negative 9. And then we're going to solve both of those. So x plus 2 is equal to 9, or x plus 2 equals negative 9. Subtract your 2, and we get a 7, or you might get negative 11. Here again, we need to double check to make sure. Typically, one of these is not going to work with these quadratics for these word problems because if you're talking about dimensions of a rectangle, obviously they have to be a positive. So I'm thinking the negative 11 is not going to work. Negative 11, if I plug it in here, negative 11 minus 2 is going to give me a negative number for the dimensions. So negative 11 is going to go away. So plugging this into the x plus 6 and the x minus 2, 7 plus 6 is 13, and 7 minus 2 is 5. So the dimensions of this rectangle are 13 feet. We're just going to say by 5 feet. Number 4. The base of a triangle is 7 less than twice its height. If the area of the triangle is 102 centimeters, find the length of the base. So still dealing with area here, just a different figure. The base of a triangle is 7 less than twice its height. So I'm going to draw a right triangle just because when we talk about area of a triangle, your base and your height have to be perpendicular. The base of a triangle is 7 less than twice its height. So the height is x. 7 less than twice that is going to be 2x minus 7. To find the area of a triangle, you will have seen this formula a lot of different ways. Area is equal to 1/2 times base times height. I like base times height divided by 2. So the area is 102. So I'm going to plug that in. So 102 is equal to the base times the height. So I've got x times the 2x minus 7, and then I've got to divide that by 2. So what I'm going to do, rather than dividing that by 2, is multiply both sides by 2. So 204 equals 2x squared minus 7x. And then from here, I would subtract the 204. And I'm going to solve by, I would probably solve by factoring. Let's try quadratic formula just for giggles. So if I use quadratic formula, I got x equals opposite b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So when we look at the discriminant here, negative 7 squared minus 4 times 2 times negative 204 gives us 1,681. And then 2 times 2 is 4. The square root of 1,681 is 41. So 7 plus or minus 41 over 4. And then, of course, split that apart to get those two solutions. So 7 plus 41 divided by the 4 is going to give us a 12. And I can already tell this next one's going to be negative. 7 minus 41 is negative 34 divided by 4 is negative 17 over 2. So of those two answers, which one's going to work? The 12. X in this instance cannot be negative. So it says find the length of the base. Well, the 12 is the height. So the length of the base is going to be 2 times 12 minus 7. So 24 minus 7 is going to be 17. And we're going to say centimeters because those are the units for that problem. Let's talk about number. Let's jump to. Let's just keep going. Number 5. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. Find the dimensions of the triangle. So when we talk about hypotenuse, we are definitely talking about a right triangle. The hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. The longer leg is 7 feet longer than the shorter leg. So one of my legs is X. We'll just call that bottom one my short leg. The longer leg is 7 feet longer than the short leg. So the other leg is going to be X plus that, 7. The hypotenuse is 1 foot more than twice the length of the shorter leg. So that's going to be 2x plus 1. So from here, the hard part about this problem is setting it up. What do we know about a right triangle in relation to the measures of the sides? Well, the Pythagorean Theorem says that a squared plus b squared is equal to c squared. Now, I'm setting this one up, and I'll give you the answer. A and b are both legs. So I'm going to take the short leg plus the long leg equals the hypotenuse. To solve this, you have to FOIL out x plus 7 times x plus 7. And you have to FOIL out the 2x plus 1 times the 2x plus 1 to finally be able to solve this. And for time's sake, I'm going to give you the answers here. The x is going to end up being 8. So our short leg is 8. Our long leg is 8 plus 7, which is going to be 15. And the hypotenuse is going to be 17. So those are the measures of the three sides of that right triangle. Number 6, moving on to number 6, the height of a rectangular prism is 3 feet. The length and width can be expressed as x minus 1 and x plus 4. If the volume of the prism is 198 feet cubed, find the value of x. So when we talk about volume of a prism, your formula is the length times width times height. So the height of a rectangular prism is 3 feet. So h equals 3. The length and width, so it doesn't specify which one's which. One of them is x minus 1, the other one is x plus 4. So what I need to do is multiply all that out. 3 times x minus 1 times x plus 4 that's the formula for volume, which is 198 feet cubed. So when we go to do this, let me get this down to the quadratic. We are going to FOIL. You can only multiply two things at a time. So I'm going to multiply the x minus 1 times the x plus 4. We get x squared plus 4x minus x minus 4. And that's going to get multiplied by 3. So 3x squared plus 12x minus 3x minus 12 equals 198. Combine our like terms. 12x minus 3x is a positive 9x minus 12 equals 198. From here, again, you're solving this quadratic. You're using one of those methods. You're using factoring, quadratic formula, or completing the square. And I think, yeah, every single one of these is divisible by 3. Everything is divisible by 3. So if I divide everything by 3, I get x squared plus 3x minus 4 equals 6. Is it 6? I think it's 66. It is 66. So from here, you can use any of those methods. Most of you are probably going to pick quadratic formula. Factoring should work. I'm going to leave this here. The answer, it says find the value of x. I will tell you that x is equal to 7. I'm not going through the last steps here just because we've already tested on how to solve a quadratic. You're going to finish this out by solving the quadratic using whatever method you are comfortable with. Same thing on number 5. I didn't finish this because you know how to FOIL and combine like terms. And then you would solve the quadratic using one of the methods that you're comfortable with from chapter 5. Moving on to question number 7, setting this up. Ken has a rectangular shaped vegetable garden that is 15 feet by 9 feet. He would like to increase the length and width by the same amount, x, so that the new garden is twice the current area. Find the value of x to the nearest tenth of a foot. So as soon as I read nearest tenth of a foot, that means my answer is not a nice integer answer. It's not going to be a whole number. So I'm thinking quadratic formula maybe on this. Anyway, let's try to set this up. There's also a couple of things going on. If his rectangular shaped garden is 15 by 9, what is the current area? So current is 15 feet by 9 feet. So 15 times 9 is 135 feet squared. So that's the current area. And his goal is to increase that by twice, by 2 times. So the new area, he wants it to be twice that, which would be 270. The question is, how are we going to set this up? He said he would like to increase the length and width by the same amount. So he wants to add some unknown number to the 15 and the same unknown number to the 9 to get that 270. And there's your equation. So he wants to take the 15 feet and add a value and the 9 feet and add a value. But he wants that new area to be 270 feet, which is double what he had before. So there's your formula or your equation for number 7. Again, FOIL the left. So you're going to FOIL the left. And then solve the quadratic using whatever method. And then, of course, answer the question that's being asked. It says find the value of x to the nearest tenth of a foot. I can tell you that x for your final answer on this one is going to be 4.7. Number 8. In your packet, you may not be able to see the inside dimensions on the inner rectangle. So there's an x here and an x plus 3 for that inner rectangle. Number 8 says, given the diagram below, if the area of the shaded region is 59 inches squared, what are the dimensions of the outside rectangle? If the area of the shaded region is 59 inches squared, what are the dimensions of the outside rectangle? So basically what we have to do here is we have to take the area of the outside rectangle and take away the area of the inside rectangle to get the area of the shaded region. So the dimensions on the outside rectangle are 2x minus 1 times x plus 6. And we're going to, I'm going to add brackets here. We're going to subtract the area of the inner, which is going to be x times x plus 3. And that should be the area of the shaded, which is 59 inches. So that's how you set that up. Let's talk about, let me get this one a little further. FOIL the first one. So 2x times x is 2x squared plus 12x minus x minus 6. So this becomes 2x squared plus 11x minus 6. We're going to subtract x squared plus 3x. And then from there, don't forget to distribute that negative and combine like terms. So we have 2x squared plus 11x minus 6 minus x squared minus 3x. So we have 2x squared minus x is x squared. 11x minus 3x would be a positive 8x minus 6 equals 59. So once you've gotten it to this point right here, again, you're going to pick what method you want to use to solve this quadratic, whether it be factoring, quadratic formula, or completing the square. It does say what are the dimensions of the outside rectangle. So once you find x, which I can tell you that x is going to equal 5 in your final two answers, you need the x is equal to 5. And then you're going to substitute that back in for the dimensions of the outside rectangle. So the dimensions of the outside rectangle should be 11 inches by 9 inches. That should be your final answer for number 8 once you solve that quadratic. Number 9, find two consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger integer is 24. So they've added a word here to the consecutive integer problems so that you know which of your two solutions that your quadratic spits out to use. So we want the positive answer, not the negative answer. So let's set this up. Two consecutive odd. So remember that when we were talking about consecutive odd or even consecutive even, we set it up the same. The first one is always x. The next one is x plus 2. So I am only trying to find 2. And there they are. I set up the first one and the second one. Again, the first one's always x because we're looking for odd. The next one is x plus 2, such that the square of the smaller added to 3 times the larger is 24. So just clean this up. X squared plus 3x plus 6 equals 24. Again, there's your quadratic. Solve it either using factoring, quadratic formula, or completing the square. Remember that factoring and quadratic formula do need a 0, so you would need to subtract the 24 before you could use either one of those methods. And I can tell you that when you solve that quadratic, you're going to get a -6 or a 3. And the -6, you're going to toss it out because you're looking for only the positive answer. So when you solve this, you're going to get x equals 3. But what are my two integers? Well, my two integers are 3, and 3 plus 2 is 5. Number 10. Find 3 consecutive positive integers such that the product of the median integer and the largest integer is 72. So I need 3 consecutive integers. It doesn't say even, it doesn't say odd. So that's going to be x, x plus 1, x plus 2, x plus 3, x plus 4, and so on. I only need the first 3. Again, the first one is always going to be x because we're looking for consecutive x plus 1 and x plus 2 to set up the equation such that the product of the median, which is the middle, and the largest is 72. FOIL out that left. So x times x is x squared. X times 2 is 2x. 1 times x is x. 1 times 2 is 2 equals 72. X squared plus 3x plus 2 equals 72. From here, you're either going to subtract the 72 and solve by factoring the quadratic formula, or you can subtract the 2 and solve by completing the square. I wouldn't recommend completing the square because the b is an odd number. You'd end up with fractions. I can tell you that the final answer is a 7, 8, and 9. Those are the 3 integers. The x that you should get is 7. You should get x equals 7. So those are your notes for Chapter 6, Lesson number 1. Again, I showed you in the beginning the methods to solve. If you wanted to use factoring, you can. If you want to use quadratic formula, you can. If you want to use completing the square, you can. I just helped you get everything set up and gave you the solutions. So those are your word problems and your notes for this lesson.